Okay, so this question is our last probability question, and it's going to talk about something that I honestly don't even remember if I taught you, and if I did, it was very sparingly. But it's going to give us kind of an overview of why the normal distribution is really useful, even in circumstances you wouldn't necessarily expect. Okay, so this is pretty cool because we're starting with a histogram, and we're going to start with stuff that we could have done Unit 1, but eventually work it to normal distribution. So what you need to notice about this histogram is that it's telling us the percent of people who have that height, okay? But what it's not telling us is exactly how tall each of these people is, okay? It's just saying that 18% have a height of 65, 14% have a height of 66, okay? And what this is called is a discrete probability distribution. And discrete means it's not continuous. And I think I did teach this year. And what's limited about this is, like, if we're looking at a normal distribution, the difference is the entire thing, you can find a probability at any point, okay? You could find the probability that it's below a really random number. Here, you couldn't do that. Does that make sense? Like, you couldn't say what's the probability that the height is less than 64.2346 inches, because all we have information on is the heights that are less than 64 and greater than 64. So this is called discrete, this is called continuous. So while this graph appears normal, this isn't a normal distribution because normal distributions are continuous. So that's just a review, like a little overview. And what A says is based on the histogram, what is the probability that the selected woman will have a height of at least 67 inches? And this is one of those things where I think you could have done it before the class, so I hope you can do it after the class. And if it says at least 67, it means 67 or higher. And all we would have to do to find that probability is add up these bars, okay? So this is going to be this, plus this, plus this, plus this, plus this, plus this. And this reminds us a bit of like the 68, 95, 99, 7 rule. Remember that when you had to kind of add portions together. And we get 27%. So that's A. B is so stupid in my opinion. And one reason it's good to go over this question is just like, because some of these questions might psych you out, but it says, what is the area of the bar corresponding to the height of 67 on the graph? And what does that area represent in terms of probability? And that is a lot of words just like to say something that's so obvious. It's saying, what does this bar mean? And all that bar means is that 11% of people have a height of 67 inches, okay? So that would be how you answer B. People are speculating on this AP that it might be like a lot of sections because the one question is like a very long question. And if it's a lot of sections, at least one or two of the sections are going to be really softball questions. So make sure you're ready for those. And you could be more specific and say like 67 to 67.999. I think this is fine because the graph's like a little bit unclear to begin with. Good. Now it gets a little bit more interesting. So I kind of, hopefully you read the question, but I kind of explained what C says. It says that it's a discrete probability model. However, the height is often considered continuous, and instead we're going to consider that this is a normal distribution. And what that means is, you probably noticed it gave us the classic information. It gave us the mean and the standard deviation. And if it gives us the mean and the standard deviation, something that you can always do is approximate data using a normal distribution. So this is really important. Really make sure you understand this. That this is a graph that explains what's happening, but we can also estimate what's happening using a normal distribution, okay? This is probably more accurate for this data set because we see, some of the sides are different than the others. However, we can estimate using the normal distribution, and it's going to give us a really similar answer. So if it ever says we're going to approximate using the normal distribution, all you have to do is take those values given to you. Okay, so if it had 64.797 and 2.66, that's just the information to make this work. Okay? So what I says is use the normal model and the relationship between area and relative frequency to find the probability that the randomly selected woman will have a height of at least 67 inches. Shitty warning. Poor wording in my opinion, but all it's saying is find this percent if it's a normal distribution, meaning 67 is the data point, 64 is the mean, and the standard deviation is 2.66. Does that make sense to everyone? You could solve it using this. We're going to estimate it using this now. So I'm going to kind of go through this a little quick because after a few examples, we should be solid here. And then convert that to percent. And because it's above, it's going to give us 1 minus the correct percent. So all we're looking for is 0.76. And yeah, 0.76 is an interesting one in my opinion. All of this, the percent, is actually really close to the z-score. So that's nerdy of me to think is pretty cool. But look, 0.77, the z-score, is also 0.77 the percent below. So yeah, this is the percent below. We got to do 1 minus that to find this. Okay, so 77% is here. The opposite would be over here. .2236. Does that make sense? And actually, in my opinion, these are farther away than I would have liked them to be. This is using the graph here. It says it's 27%, and using the normal approximation, we get 22%. But that's what it's asking us to do, so that's fine with us. So that was I for C, and then, or I guess you call it I and double I. Okay, so on C double I, we have, does your part CI match your answer in part A? Oh man, I honestly didn't even read this question, but I'm anticipating. It's saying now we want to give a reason why. So what we were talking about is like how these values are different, and we can say something simple here. Let's just say that the normal distribution only approximates the data and isn't 100% accurate. I'm going to write what you could come back to if this is in your notes. If it asks you something like this, if you see a question like this, you can use this phrase, using the normal approximation only gives an estimate while the graph itself is more accurate. And then for D, it says, and we're talking about a random variable again, so remember, this is the last probability thing, but everything always ties together. It says, and I haven't even read it yet, I hope it's good. Let the random variable H represent the height of a woman in the population. The probability that it's less than 60 represents the probability of randomly selecting a woman with a height less than 60 inches, based on the information given. Okay, so I think this is actually pretty tricky. What I'm the most worried about on the AP is something like this, where it's kind of asking you to have some explanations, and your math might be pretty good, but your logic might be a little bit lacking for some of this. Okay, so what's up everyone? We're back at it with this question, and it's flustered, and the video just changed randomly because I took a whole day kind of thinking about this, or like I did other questions because I was confused on how to approach this last section. Because I looked at the answer keys and I really wasn't satisfied. So that's kind of is my answer. I'm not 100% satisfied with this last question, but let's just talk about it because there's definitely some stats that we can learn from it or think about from it because it's a close to a cool question. But it's saying that we know for this question that there's two ways that we're estimating these probabilities with this histogram with the bars and having it be a discrete random variable because each bar represents a value and they're separate, or a continuous variable. And what D is essentially asking us is, for this, is there anything that this can solve but this can't? And is there anything that this can solve that this can't? And the first one to me is a little easy. And it's saying, or the second one, 2 is easy to me because 2 is saying what's something that this can do that this can't do. And maybe pause the video to think about this logically, but think how limited this graph is. If this bar represents 65 to 65.9999999, there's no way for us to estimate something like 65.5 to 66.5. You know what I mean? You can only measure this distance, all 65s. But here, you can measure anything. And that is what a continuous variable is. Because that, like, we could do 67, but we could do 67.1, we could do 67.00001. All of that we could do with a normal distribution. Okay? So that's an example. We could just say 65 to 66.5 of when we could use the normal model, but not the discrete model. So let me write that down. Okay. So that is the easier part. And then I disagree with the answer key, honestly. And this question, I'm taking all these from the College Board website, and they have certain levels of like how close it aligns with the course itself. And this one was like a strong but not perfect like alignment with the course. And I read through what they said, and I don't think it made a lot of sense. Okay, so what it's trying to ask us is what's something that we could do here, but we couldn't do here. And if it's continuous, the real thing is you can do any value. Okay, you can measure any point to any point. You can measure exactly to the infinite number of decimal places. But this still has a weakness, okay? And that weakness is that it's less accurate than this graph, because all this is saying is that we know the mean and the standard deviation, and this is approximately normal. Okay, it's saying we're going to use the normal distribution to approximate it, but this is actually going to be more accurate for something like 65 to 65.99999. I hope that makes sense to everyone. When we use the normal distribution, if the question says it is normally distributed, that's good, but a lot of times it says, but this one is saying that height is often considered continuous and follows a normal model. So it's saying that it often does, so we're going to use it to model this, okay? But this is not as accurate as this. I mean, there are little distinctions, right, where this is higher than this is higher than this. So it's not exactly normal. So if I'm going to say answer D, what I'm just going to say is the normal distribution can predict anything, but with less accuracy oftentimes than the discrete model. So let me just read what I said. It said the normal distribution can predict any interval, but with less accuracy than the discrete model because it's an approximation. So that's that. I think this question is still definitely worth doing. And yeah, we're crushing it. Woo!